In this video, we'll be discussing Module 5, Loops. So, repetition and looping are very important in programming because most programs require the same logic to be repeated for several sets of data. So, it saves a lot of time to use a loop to accomplish this rather than having to manually repeat lines of code more than once to tell the program to do something more than once. Sometimes you may not even know exactly how many times something needs to repeat, and that's why a loop allows you to set a condition so that a set of instructions will repeat as long as a condition exists. Much the same as the if-then statements, where you have a path if the condition is true and a path if the condition is false. The conditions are set in the same way, but instead of just having two paths, it will determine how many times a set of instructions will repeat. To put it in a real-world example, if you look at the picture, imagine that you're trying to paint over a dark color wall with a light color. So if you've ever painted anything before, you know that sometimes it can be difficult to cover up a darker color like that. You may have to put several coats of paint. So the process for that would be something like put a coat of paint on the wall, let it dry, check to see if you can still see the previous color through the paint. If you can, then you should repeat the process of painting the wall. And you would continue that process over and over until you have put enough coats of paint on the wall that you can no longer see the paint underneath. And once that condition becomes false, the condition that you can see the paint, so once you cannot see the paint, the old paint under the new paint, then you would stop repeating that process. So much the same way with loops in programming. That condition will determine when the instruction should be repeated and when that repetition should stop. So there's three ways a set of instructions can be repeated. At the beginning of the loop, which is a leading decision loop, at the end of the loop, which is a trailing decision loop, and a counted number of times, which is a counted loop. So we'll look at each of these examples and how they work and when it would be best to use each one. So the first thing we'll look at is the leading decision loop, or the while loop. It's referred to as a while loop in Flowgorithm and in other programming languages. But the condition is tested before any statements within the loop are executed, which is why it's called a leading decision loop. So it will check for the specified condition before it does anything. The only way to terminate the loop is for the while condition to become false. So you have to make sure that a process is set up within the loop statements that will eventually allow that condition to become false. Otherwise, it will become an endless loop. So in our example, the problem statement is a program is required to get two numbers from the user and display the sum, product, and average of the two numbers. The program should not accept zeros as input. So we'll look at this in Flowgorithm. So the first thing we have is to declare our variables for number 1 and number 2, allow the user to input those numbers, and where we have the while loop is a mechanism to check and make sure those numbers are not 0, because the program is not supposed to accept numbers equal to 0. So if we were going to add a new while loop, when I click on the arrow in Flowgorithm, you can see under the looping category our three options: while, for, and do. And we'll be looking at each one of these, but the while loop, when I click that, this is how it looks when you first put it into the flowchart, and if I double click on that shape, I can enter a conditional expression. Now the conditional expression just like with the if statement, you would format this the same way. You can use the same operators, so greater than, less than, equal to, not equal to, so on and so forth. You can also use the and or keywords. So if you have more than one condition that you need to check for, you can use those keywords to combine the two conditions. In this case, instead of it just choosing the true or false path, as long as the condition here is true, then the statements within the loop will continue to run. When the condition becomes false, then it will take the false path, which exits the loop and continues on with any code under that loop. So once we have specified a condition, I'm just going to delete this while loop out. So here I specified the condition number 1 equals 0 or number 2 equals 0. So if you remember the or keyword, either one of these conditions being true will make the entire statement true. So if one of these numbers is 0, then it will take the loop path, the true path, and it will let the user know, please enter numbers other than 0. And then it gives them a second chance to input number 1 and number 2. So once they have the chance to input these numbers again, it will change the values of those variables from what they put in at the beginning, and it will then check again to see if number 1 or number 2 is equal to 0. If either one is still equal to 0, it will tell them again, please enter numbers other than 0, and it will keep going until they change both numbers to something other than 0. Once they do, it will take the false path and it will perform the calculations that were specified in the problem statement. So let's just run this and see how it works. Enter your first number. I'll make the first one 0. Enter your second number, 7. Please enter numbers other than 0. Alright, so I know I'm putting in number 1 again. This time I'm going to change that one to 5, but I'm going to put number 2 in as 0. Please enter numbers other than 0. If I put 2 zeros in, please enter numbers other than 0. So you can see it keeps repeating that until I change both of them to something that is not 0. Once I do, it moves past that loop and finishes out the program displaying the results. Now you can use a while loop to repeat a known number of times. So if you know how many times a certain set of instructions needs to be repeated, then you can use a counter. A counter is initialized the same way you would initialize a variable, but the sole purpose of the counter is to increment a number to count how many times that this loop has run. In this example, the problem statement is a program is required to get a set of 15 temperatures in Fahrenheit from a user, convert each one to Celsius, and display each temperature in Celsius. So looking at this in Flowgorithm, the counter here, I have declared it as an integer variable, and I just named it temp count. And then before entering into the loop, you have to make sure that you initialize and set the counter to a value. So you start out with 0. So as it runs, it will be able to start out with that value of 0. Otherwise, there's no value stored in there, and so it wouldn't know where to start. And then for our while loop, the condition is temp count less than 15. So it's pretty simple. It will check and see if that counter is less than 15 and how many times it has run. Now, when you start out with the value of 0, zeros count. So that's why I have it as less than 15. It's supposed to run 15 times, but the 0 counts as the first time. So it will count up to the value of 14, and then it will have run 15 times. So as long as that value is less than 15, this should keep running. So in the loop itself, it will ask the user to enter a temperature in Fahrenheit. They'll input the temperature. It will run the calculation to convert it to Celsius, and it will display that temperature in Celsius. Then, this is the important part of using the counter in the loop. I have temp count equals temp count plus 1. So to increment this counter, I refer to the variable temp count, and I set that equal to whatever the previous value of temp count was plus 1. So every time this loop runs, it will add 1 to that count. And that's how when it reaches the check for the while loop again, it will be one number higher, and it will be able to tell how many times this loop has run. When it finishes the 15 times, it will go to the false path, and it will output all temperatures have been processed. So let's just run this and see how it works. So I'm just going to put in some random temperatures. Alright, so as you can see from our output, each time the loop ran, it allowed me to enter a temperature in Fahrenheit. It converted the temperature to Celsius. Then it asked me for another temperature in Fahrenheit, gave me the temperature in Celsius, and it continued that. $15 times. And when it finished the 15 times, it output all temperatures have been processed. So that's how you would use that while loop to run a set number of times that you know how many times that needs to run. You can also use a while loop to repeat an unknown number of times. So with the example of using it as a data validation tool to make sure that those numbers were not 0, it was something similar. So we're looking for a certain condition to end the loop. If you don't know how many items need to be processed, and it's not something like checking to make sure that the data is valid, you can use a trailer record or sentinel to signify the end of the data. This record has to be clearly distinguishable from the other data to be processed, so it needs to be outside the range of expected input. In this example, the problem statement is a program will have the user enter students' exam scores. As each score is entered, the scores will be added together. When the user is finished entering records, the program will calculate and display the average exam score for all student records entered. So let's take a look at this. First, we declare our variables. We have total score, so that will be as the exam scores are added together. Total students will count the number of students that have been put in. Total score and total students we initialize to 0. And then we have a variable for the exam score as each exam score is put in. So it's important to explain in your instructions for the program when you're using a sentinel record to tell the user how to make use of that. So in other words, they need to know what they should put in to end the program. In this case, we're going to use an exam score of 999 as a Sentinel record. That's because this is far outside the expected range of scores. An exam score should be from 1 to 100. So if the value 999 is put in, then that would not be a valid exam score. So it's a good Sentinel record to use to trigger the end of the program. So we explain this in the initial instructions to the user that when you're done, enter 999 to end the program. So it asks for the first exam score. The exam score is input. And then here our while loop will check to make sure the exam score does not equal, which remember that is an exclamation point and an equal sign to mean not equal to 999. As long as the exam score is not equal to 999, it will continue running this loop. So the first thing it does is it increments the total students to total students plus 1, and it increments the total score to equal total score plus the exam score that was just entered by the user. So we need to have the count of the total number of students increase by 1 every time a record is added, so that when it reaches the average calculation, it will know how many students to divide that by. Then it will add the total score, add to the total score the next exam score, so that that can also be used in the average calculation. And then finally, the final step in the loop is to input the exam score, the next exam score. So that has to be at the end so that it can check again to see if the next record is 999. So it needs to perform that check every single time to be sure that it hasn't reached the Sentinel record. Once it does, and the user puts in 999 to end the program, then it will take the false path, so that condition's false, and then we've used an if statement here, total students greater than 0. So that way, in case up here the first thing they put in is 999, then the program will know that no records were entered, and it can output no student records have been entered. As long as the total student count is greater than 0, then it will take the true path and it will average the score, so it will divide the total score by the total number of students, and then it will output that average score. So the key things here for using a while loop for an unknown number of times is that you need to use a Sentinel record of some sort, something that is outside the expected inputs, and that will trigger the loop to stop, and make sure that you explain to the user how they can stop the program. So what Sentinel record do they need to enter to end that program. Now we'll look at the next type of loop, which is a trailing decision loop, or a do loop. With this type of loop, the condition is tested at the end of the loop, so that's why it's called trailing decision. Statements within the loop will be executed one time before the condition is tested. If the condition is true, then the statements will be repeated until the condition becomes false. So just like the while loop, as long as the condition is true, it will run. The only difference is with a while loop, if the condition is false initially, nothing in the loop will ever run. With a trailing decision loop, the do loop, then it will run one time before it even checks for the condition at all. So the statements in the loop will always execute at least once. In this case, there is no need for a priming statement because of that. So what that means, a priming statement, is in our while loop, we had to get input from the user first so that there was something for that condition to check. So outside the loop, we had to get the exam score from the user. In this case, because the statements will run one time before checking the condition, we can simply collect that input as part of the loop. We don't have to have it before the loop. So again, we're looking at the exact same problem statement, just using a different type of loop to accomplish this. So in this case, most things stay the same in the program, but instead of using that Sentinel record of 999, I've created a string variable called more records. So as you can see in the instructions, it tells the user to continue entering exam scores, and when you're finished, enter no to end the program. So as the loop runs, it will ask the user, do you have more student records? Please enter yes or no. So as long as more records equals yes, then the loop will continue to run. So you can see just from the structure that the loop will run one time, so it will ask the user to enter an exam score, add 1 to total students, add the exam score to the total score, and then it will ask if the user has more student records and get that input. So this will run no matter what, at least one time. The check is performed at the end, so more records yes, it keeps going. If more records equals no, then it exits the loop and it performs our average calculation and displays that. The last type of loop we'll look at is the counted loop, or the for loop. So this is used when the exact number of loop iterations is known in advance, and it's controlled by a loop index. So we looked at how to use a while loop to accomplish this, but the counted loop makes it a lot easier when you do know the number of times that the loop needs to run. The useful thing about this is that it performs the initializing, incrementing, and testing of the loop counter automatically. The loop is terminated once the required number of repetitions have been executed, so there's no need to check for a specific condition other than checking what number the counter is on. So we're back to the problem statement of a program is required to get a set of 15 temperatures in Fahrenheit from a user, convert each one to Celsius, and display each temperature in Celsius. So the same problem statement we had earlier, but this time instead of using the while loop, we'll be using the for loop. So everything remains pretty much the same except for how the loop itself runs. So with a for loop, it's a little different when you first put it in, so I'll show you how it looks to begin with. So if we double click this, instead of just specifying a condition, you can see there's more options here. So we specify the variable, which in this case we did have to declare the temp count variable. So you still have to declare that to use it as a counter. Then we have a start value and an end value. So we can specify the values, and remember 0 counts, so that's why we have 0 to 14. We can specify increasing or decreasing, so if it's going to add 1 or subtract 1 each time the loop runs. And then step by, so we want it to increase by 1 each time. You could change this to increase by 5 each time or 10 each time. So there may be other uses for that you'll find. But in this case, we've left it pretty simple to just step by 1. So you can see how I input the details of this for loop. So now temp count equals 0 to 14. So what that means is as long as temp count is from 0 to 14, this loop will continue running, and when it's finished, it will exit the loop and say all temperatures have been processed. So we're going to compare these different types of loops to see where they're most useful. So let's compare the while loop with the do loop. So this is back on our exam score problem. So there's a few differences that you can notice, and I've kind of cropped it to just look at the loops themselves. So before the loop starts, we had to get the exam score so that the loop condition would have something to check. And then once the loop runs, at the end we have the user input the exam score again, and it proceeds to check over and over until the Sentinel record 999 is entered, and then it exits the loop. With the do loop, it simplifies it because we did not have to get the exam score initially, because these steps will run at least once. So we can simply get the exam score as part of the loop and use the more records variable for the user to indicate if they are done or not. So the do loop can simplify this versus needing that specific Sentinel record. Here we have the while loop versus the for loop. So when you know the number of times that a loop needs to repeat, the for loop simplifies it. So with the while loop, we had to create a counter, and within the loop we had to increment the counter, and it also had to be initialized, so we had to set it to 0. And then the condition temp count less than 15, within the loop temp count equals temp count plus 1. So we had to do all of that manually. With the for loop, as you saw when we created the loop, we put all those details in the loop itself. So we were able to just declare temp count, but we didn't have to initialize it. We didn't have to increment it. It did all that automatically. So every time this runs, it automatically incremented temp count all the way from 0 to 14 so that it would run 15 times. So again, the for loop is simpler when you know the number of times it needs to run. So you might be saying, if the do loop is better for than using a while loop with a Sentinel record, and the for loop is better than using a while loop when you know the number of times it needs to run, then why does a while loop exist? Well, there are times, like when you are doing data validation, that you don't need the loop to run, like with the do loop. You don't need that loop to run at all unless a certain condition is met. So you would want to use a while loop so that those steps don't run unless they need to. So just like with the adding the two numbers, and you don't want the input to be 0. The only time that loop was going to run was if one of those two values was 0. There's no need to tell the user there's an error if they didn't do anything wrong. So that is the main case where the while loop is essential, is because you wouldn't need those steps to run if there's no error. So the do loop is when you want the the loop to run at least one time before it checks for anything. And then of course your for loop, the counted loop, is when you know the exact number of times. But the while loop definitely has its place as well.